Dear colleagues, I welcome you on the second section of the second international workshop on computer information technologies in Industry 4.0. My name is Vasil Duzorsky, and I am the secretary of this workshop. The organizers of the workshop are Pavlo Marushchak, Doctor of Science, Professor, Vice Rector of Scientific Work of Ternopil Ivan Paluy National Technical University, and Andrei Sverstyuk, Doctor of Science, Professor of Medical Informatics Department of Ivan Gorbachevsky Ternopil State Medical University. Let me start with brief statistics. 73 papers were submitted to this workshop, both from universities in Ukraine and abroad. In particular, papers came from more than 50 Ukrainian universities, as well as from Algeria, China, France, India, Kyrgyzstan, Morocco, Poland, and United Kingdom. Based on the program committee review results, only 29 best papers were accepted for this workshop. And now, regarding to the workshop regulations. According to the workshop program, authors are given up to 10 minutes for the presentation and discussion of each paper. During the workshop, changes are possible in accordance with the situation in Ukraine. In particular, in the case of air alarms, there will be breaks, and continuation of the workshop will be after the air alarms are over. Also, in the event of a power outage, and the author's inability to present their scientific results, I'll turn on a corresponding video presentation if they are available. And taking into account the difficult situation in Ukraine and unpredictable factors, the workshop is held over 3 days. Authors who were unable to present their papers according to the workshop program will have the opportunity to do so during the following days of the workshop. So, according to the workshop program, sitting papers will be given today. And the first report is Industry 4.0 Technologies for Smart Households, authored by Dmitriev, Alexei Duda, Pavlo Dudkin, Andrei Kryskov, and Olga Perenchuk.
Dear colleagues, we bring to your attention an article on the topic Industry 4.0 Technologies for Smart Households. Industry 4.0 is a convergence of the physical and digital worlds in production processes. This is the fourth industrial revolution which uses the mass integration of information and communication technologies based on the Internet of Things in production. At the same time, data is collected and analyzed in real time to optimize processes to improve efficiency and make decisions. Industry 4.0 has significant potential for digital transformation of the production process. It can make it more efficient, flexible, and sustainable. This leads to the creation of new products, digital services, and business models. This causes a number of challenges, in particular high cost of implementation, social, security, ethical, etc. At the same time, Industry 4.0 provides a number of advantages: improvement, increasing new products and digital services creation, task automation, process and services remote management, reduction, etc. Mass integration of Internet of Things and information and communication technologies make it possible to connect a wide range of devices, sensors, mechanisms, machines, and other elements of production to the Internet. Large data sets and collection are produced in real time. Information communication technology is used to collect, process, analyze, and visualize data. This provides better control of processes in decision making. Cyber-physical systems are used to combine physical components with computer systems. This makes it possible to create smart machines, locations, and factories to formation smart digital services. They can independently adopt and quickly respond to rapid changes in the environment. The artificial intelligence and machine learning are used to predict, automate, and optimize processes. A smart household is based on the information technology concept of a smart home. A smart home is a residence equipped with technologies that enable the automation and control of various household devices, systems, and processes. Transmitters and sensors that collect data about the environment, in particular humidity, air composition, the presence of salt particles, illumination, movement, resource consumption, etc. Actuators controls household and household appliances and devices, lighting, security systems, processes, etc. Data storage facilities make it possible to store large and fast-moving sets and collection of data accumulated as a result of the operation of transducer sensors and actuators. Peripheral, fog, and cloud storages are used for operation and storage of information in smart household systems. Controllers process data from sensors, make decisions, and send commands to actuators. Analytical tools are used to process, systemize, and analyze the collected data sets of a smart household. User interfaces enable residents to control household systems using smartphones, tablets, or personal computers. Industry 4.0 technologies make smart households more comfortable, safer, more economical, and more environmentally friendly. Industry 4.0 has a significant impact on the development of smart households in a number of key aspects, increasing the connectivity of data collection and storage processes, automation of management processes, personalization and adaptation, energy efficiency and sustainability. Industry 4.0 opens up opportunities for the development of innovative information technology products and digital services of a smart household. Industry 4.0 is constantly developing. At the same time, new technologies are emerging that can be used to improve smart households. Smart homes are expected to become more common and affordable in the near future. A significant part of smart household systems can combine the functions of several categories. For example, image recognition systems can be used both to identify residents and monitor the activity of the elderly. This makes smart households personalized, adaptable, and flexible. Industry 4.0 technologies play an important role in the design and implementation of smart households. Smart households implement innovative digital services, increase the efficiency of process management, optimize the use of resources, and improve the quality of life. Thanks to Industry 4.0 technologies, smart decision support systems are being developed that effectively manage user identification, access rights distribution, and privileges. This increases the security of data collection and processing, leads to an improvement in the efficiency of the use of systems, and reduces operating costs in general. The implementation of information technology projects for smart households demonstrates how the use of advanced technologies in Industry 4.0 contributes to the improvement of efficiency, sustainability, and quality of life for citizens. By deploying digital solutions based on Industry 4.0 technologies, smart households can form interconnected and efficient infrastructures of smart locations, smart communities, and smart cities. They offer a wide range of smart services in real time. One of the promising areas of further research is the specifics of the integration of smart households in higher order systems. Industry 4.0 technologies and smart households are actively evolving. Therefore, it is advisable to further investigate the features of forming information and technology platforms for smart households and the details of interaction between their components. Thank you for your attention.
Thank you. And next report is Mathematical, Algorithmic and Software Support for Signals Wavelet Detection in Electronic Communications, authored by Lila Хвостівська, Микола Хвостівський, and Irina Dediv. So please present your paper.
Hello, everyone. We are glad. Excuse me.
You may press on share screen and select your presentation.
Okay. 1 second. Excuse me, host disabled participant screen sharing. I can't share in my screen.
Okay. 1 moment. And now, please try again.
Hello, everyone. We are glad to be a part of this event. Hello, everyone. We are glad to be a part of this event and present our work. The title of our paper is Mathematical, Algorithmic and Software Support for Signals Wavelet Detection in Electronic Communications. Authors Lilia Хвостівська, Микола Хвостівський, Irina Dediv. An important problem for scientists in the field of electronic communications research is the process of reliable detection of useful signals as the first stage of phasor processing of the signal with the accurate determination of the useful signal in its composition. For detect signals are used computer tools, in particular the software, which is implemented on mathematical support. In particular, correlation, cross-correlation, neural networks, synphase component, and wavelet processing in the moral basis. All of them maintained methods except for wavelets do not make it possible to research fluctuation process in the structure of the studied signals, which is actual for the detection and subsequent identification of useful signals in electronic communications with the noises when taken into account the parameters of time variability and time shifts. In electronic communications, all the linear type signals are described by an additive image, which is shown in figure 1. The image of the signal model, figure 1, provides a description of such signals in electronic communication through the summation of noises that are formed by external internal influence. Figure 2 shows an amplitude-modulated signal with noise. The amplitude-modulated signal, figure 2, is characterized by randomness due to noises and repeatability of the modulation process during transmission. The values of amplitude of the signal change in time with the value of a certain deviation in relation to the average value of the useful signal, which leads to a function thing as can be seen in figure 2. If you study the fluctuation sync of the signal in time-space, then accordingly you can quickly detect useful signals in an interfering environment. Method of wavelet transformation with different bases constructively provides the process of studying fluctuations in the structure of signals and at different time scales. The core of the wavelet signal detection method by its wavelet processing is based on the following expression 1. The mother basis function in expression 1 provides the definition and the study of the fluctuation process in the signal. Mexican head and mullet as present functions are structurally similar to real modulated signals, taking into account the indicators, so the use of these functions or for correlation from signals is well. The Mexican head function is formed by double differentiation of the Gaussian function expression 2. An example of the implementation of the Mexican head is shown in figure 3. Figure 4 shows the wavelet algorithm for detecting signals. The following operations are shown in figure 4. The first is wavelet processing of signals in interfering electronic communications. 2. Calculation of the Fourier transform. 3. The process of making decisions based on morphological analysis of or visual analysis regarding the presence of a useful signal in electronic communications with noises. When estimating values of wavelet spectra of signals, the procedure of averaging values by time shifts was applied using the expression 3. When using wavelet processing expressions in the Mexican head base, an algorithmic support for signal processing has been developed for its detection in the form of an algorithm which is shown in figure 5. The result of wavelet detection of signals in the mother in the base of the Mexican head under the influence of noises with root mean square deviation at the level of 0 to 0.6 volts squared in the form of spectra are shown in figure from 6 to 9. Based on the results of wavelet detection, figure 6 to 9, it can be determined that the component of the wavelet spectrum of the useful signal is clearly localized in electronic communications with noises with different levels of of noises from 0.2 to 0.6 volts squared per 500 displacement on all numerical scales. Statistically, evaluated 3D representation of the signal spectra at the as the level of noises 0 to 0.6 volts squared is shown in figure 10 to 13. The average realizations of wavelet spectra allow for a more detailed comparative analysis of data in compression with 3D representations of spectrum. The use of the guide Autolita in the MATLAB environment made it possible to develop automated wavelet signal detection software with noises in electronic communications. The software interference and the detection result are shown in figure 14. The developed software provides a correct, reliable, and accurate process of automated wavelet detection of a usable signal in electronic communications with noise. They implemented mathematical, algorithmic, and software for wavelet detection of useful signals in interfering electronic communication based on wavelet processing with the mother base function Mexican hat made it possible to increase the number of pitches for detecting the type of wavelet spectra of 3D and 2D types that reflect the fluctuating processes of signals and visually and quantitatively indicate the presence, absence of useful signals against the background of noises of different power. Thank you for your attention.
Thank you for your report. Dear colleagues, maybe you have some questions, please ask.
I have one question. May I ask?
Please.
Okay, I have such questions. What software procedures have you developed in MATLAB environment for implementing automated software of detecting signals with noises in electronic communications?
The following property software function have been developed for the implementation of automated software for signals with interference in electronic communications is in particular the first is a software function for processing signals from the base of the Mexican hat to calculate 3D wavelet spectra as detection indicators. The second is software function of downloading useful signals from the database, and third is a software function for evaluating the results of signal processing when they are detected in a family with tests.
Okay, thanks.
Thank you. Maybe another questions? No questions. So thank you for your report. And the next report is understanding the ADAM optimization algorithm in machine learning, authored by Олесь Господарський, Василь Марценюк, Натаlia Kucharska, Andrei Господарський, and Sofia Sverstyuk. Please, are the speakers present here?
Yes.
Oh, so please.
1 second. Can you see the presentation? Okay. Welcome everyone. Our topic is understanding the ADAM optimization algorithm in machine learning. The purpose and the objectives. Our main goal is to explore how the ADAM optimization algorithm works, both in theory and in practice. Also, we want to compare how well the ADAM optimization algorithm performs compared to the other advanced methods when applied to common datasets. And additionally, we aim to evaluate how accurately the algorithm can identify and categorize our test dataset. This will help us understand its strengths and possible weaknesses in real-world use. Let's start with what machine learning is. Machine learning and artificial intelligence are significant areas of interest in both contemporary science and society. They represent some of the most advanced technologies applicable across various industries, including healthcare, finance, transportation, and entertainment. Key figures in machine learning include Geoffrey Hinton, who pioneered many modern techniques, Yann LeCun, known for his convolutional neural networks works, and Yoshua Bengio for language processing and unsupervised learning. As we dive into the fundamentals of machine learning, let's start with understanding what a machine learning model is. Essentially, it is a program that learns from data to make predictions or decisions, eliminating the need for explicit programming for each specific task. There are three primary types of machine learning. Supervised learning, where the model is trained on labeled data. The model learns to map inputs to the correct outputs. The unsupervised learning. In unsupervised learning, the model is trained on unlabeled data and must find hidden patterns within the input data. And reinforcement learning. This model mimics how humans learn from experience. This model interacts with its environment, makes decisions, and learns from the consequences. As we continue, it's important to note that our focus will be on neural networks and supervised learning, particularly because we will be discussing the ADAM optimization algorithm, which is widely used in training these types of models. To understand how a neural network works, we need to understand its basic structure, which can be broken down into several key components. The input layer is the initial layer of the model where the raw data is fed into the system. Between the input and output layers, we have one or more hidden layers. These layers perform the core computations and transformation on the input data. And the output layer, where the model generates its predictions. The structure of this layer depends on the specific task. Weights and biases are the parameters that the neural network adjusts during training. Optimization is a fundamental aspect of machine learning, and when the input signal is received by the model, it undergoes processing through a function, and after a series of computation, it transforms into the output value. Then the model compares the generated output value with the actual value and computes the metric called the loss function. The loss function is a measure of how well the model performs on a given task. You can see some of the basic loss functions used in machine learning on this slide, which are mean squared error, mean absolute error, and binary cross entropy. Next, we need to find an optimization algorithm capable of efficiently minimizing the loss function. The effectiveness of an optimization algorithm is crucial because it influences how quickly and accurately the model converges to an optimal solution. To illustrate this, let's look at two graphs. The first graph shows a model with poor accuracy, where there is a significant mismatch between the predictions and the actual values. The second graph shows a model with better accuracy, where the predictions closely match the actual values. To achieve such results, different algorithms are used. Their task is to adjust the model's parameters, specifically the weights and biases, so that the model learns to make more accurate predictions. And the first algorithm we'll look into is gradient descent. The idea of gradient descent is to update the parameters of the model by moving in the direction of the steepest descent of the loss function. The gradient descent calculates the derivative of the loss function concerning each model parameter to determine the direction of the update. The algorithm updates the weights by subtracting a fraction of the gradient from the current value of each weight. This function is known. This fraction is known as the learning rate, denoted by alpha, and it controls the size of the step taken in the direction of the negative gradient. This process is repeated iteratively, and with each iteration, the algorithm progressively approaches a local minimum loss function. Standard gradient descent requires computing the gradient of the loss function over the entire dataset, which can be resource intensive, especially with large datasets. Therefore, in such cases, stochastic gradient descent is applied, which is more efficient for optimizing models with large amount of data. Stochastic gradient descent computes the gradient and updates the weights for each data sample in the dataset separately. That is, on each iteration, SGD uses only one data sample instead of the entire dataset, allowing for quick weight updates and more efficient processing of large datasets. However, SGD can be sensitive to the initial values of the weights, causing it to get stuck in a local minimum and fail to find a global minimum of the loss function, as you can see on the slide. That's where ADAM comes in handy. It uses the history of previous gradients to adaptively adjust the learning rate for each parameter, helping to overcome the limitations of SGD. ADAM was presented by Derek Kinma from OpenAI and Jimmy Ba from University of Toronto in their paper titled ADAM, a method of stochastic optimization. In Atom, a separate learning rate is maintained for each parameter weight, which is adapted and updated individually. The algorithm selects a smaller learning rate for frequently updated parameters and larger one for parameters corresponding to rare features. The Atom algorithm computes the exponential moving average of the gradient. It is called the first moment, and the squared gradient, the second moment of the weights, where the parameters beta 1 and beta 2 control the smoothing rates of these moving averages. In the context of exponential moving average, as shown as a figure, smoothing occurs by assigning more weight to newer data. Thus, the model responds more to the recent changes in the data than to older values, allowing to adapt to any new data trends. The first and the second moment are statistical concepts. In the context of Adam optimization algorithm, the first moment is used to estimate the mean value of gradients, and the second moment is used to estimate the variance of gradients, reflecting how gradients are spread around the mean value. The main idea behind using moments in Adam is to provide the algorithm with additional information about previous weight updates, enabling better control over optimization process. Adam's update rule is shown on this slide, as you can see. Here, the value m is the first momentum, and the value v is the second. To measure the effectiveness and universality of the atom, we compared it with other optimization algorithms on two datasets, MNIST and FashionMNIST. We chose them because they are often used as a benchmark for testing new machine learning algorithms and models. MNIST is a classical dataset consisting of black and white images of handwritten digits, and FashionMNIST is another popular dataset that has various types of clothing items such as t-shirts, dresses, trousers, etc. FashionMNIST consists of more complicated pictures than MNIST, and by evaluating Adam's performance on these diverse datasets, we can see how well it works across different types of data. The first figure on this slide illustrates the training process of model on MNIST dataset using various optimization algorithms. The results indicate that despite the fact the task not being very complicated, Adam successfully demonstrated the best performance among the algorithms with accuracy around 97.63%. The second figure illustrates the training process of models on the FashionMNIST dataset. Despite more complexity, Adam managed to outperform other algorithms, reaching the accuracy of around 90.56%. To make sure our model works well for our specific needs, we made a small dataset ourselves. The famous MNIST dataset, created by American researchers, may not match our handwritten numbers perfectly, so we wanted to see if our model could still understand and categorize our characters correctly. This way, we could check if our model is flexible and reliable for our purposes, not just for standard datasets. The test dataset consists of 100 handwritten numbers from 0 to 9, and the results appear promising, with the model achieving the accuracy of 97%, meaning it correctly predicted 97 of 100 images, which is a very good result, considering that the model accuracy on MNIST dataset was 97.63%. In conclusion, we can say that the Adam algorithm is an effective optimization method that combines ideas from other algorithms such as Hermes-Prop and AdaGrad. Experiments on various datasets such as MNIST and FashionMNIST show that the Adam algorithm is capable of achieving good results across the wide range of machine learning tasks. And the Adam algorithm is effective for optimizing tasks involving both large and small datasets, as demonstrated by experimental results. Thank you for your attention.
Thank you for your report. Dear colleagues, any questions, please ask, if any. No questions. So thank you again for your report. And the next report is robotic arm concept for surgery, integrating of 3D printing and IO technologies, authored by Pavlo Tymkiv, Alexandra Klosvitkovska, Жанна Babiak, Victor Koshelyuk, and Andrei Golovko. Please.
Good day. You can see my presentation, yes?
All is good, please
Thank
continue.
you. One moment. Good day, colleagues. I present our latest development in the field of robotic surgery. Our work focused on creating a cutting-edge robotic manipulation RM designed by the Signification Superpass. Robotic surgery has since obtained advancement over the past few decades. The integration of the robots into surgical procedure offers numerous benefits, including enhanced precision, reduces the trauma, and accelerated patient recovery. However, current the systems such as Da Vinci or Zeus face several limitations. This includes high operation cost, lack of tactile feedback, and restricted range of motion. A prominent example of a robotic surgical system is the Da Vinci surgical system. It comprises the two main units, a control console for surgeons and robotic manipulation unit, which performs the surgical tasks. The Da Vinci system is used in hundreds of clinics worldwide. One of its robotic RMs holds a camera that provides a real-time 3D view surgical site. While the two another RMs replace the surgical hands movement. Another example, Zeus robotic surgical system, which are similar to Da Vinci, but Zeus included a control console and 3 robotic RMs to attach to the operation table. The right and left hands RM mimic a surgical movement, while the third RM, a voice-controlled robotic RM navigated and endoscope. The console feature in a monitor are ergonomically placed control hands, and it can be both traditional laparoscopic instruments. Current challenges in robotic surgery. Today's robotic surgical system encounter two primary challenges: lack of tactile feedback. Surgeons cannot feel the tissue they're working is on, and limited range of motion. The movement of a robotic instrument are considered by the mechanical design. Our project aims to address this issue by developing an advanced robotic manipulation IRM. Our solution. Our robotic IRM designed by a principle of bionic prosthesis and aim closely mimics the structure of human hands. Major components are produced by 3D printing technology, which reduce abuse both weight and cost. The RM powered by SG90 servo motors. Finger flexion is achieved using the mechanical traction prosthesis. Control console, ergonomical design for use to console and manufacturing using 3D printing. Equipment with the 5 primary control elements joystick are easable and surgery fingers. And a feedback mechanism. Sensors embed each finger distant, measure dynamic and static loads. The control console is fitted with actuators to provide a tactile feedback to surgeons. Artificial neural networks are incorporated into feedback and loop the movement, coordination, and precision and speed. Our development have a title feedback. Surgeon can feel to see the operation on anthropomorphic design. The robotic IRM replaces the natural movements. Intelligent system, the integration of artificial neural network optimization, the control and coordination movements. Cost efficient, the use of 3D printing significantly reduce the manufacturing cost of the robotic IRM. And IoT integration, the potential is integrating Internet of the Things technologies, allows for the real-time monitoring and control surgical procedure, further precision and safety. The purpose Robotic manipulation IRM hold a potential robotic surgery by addressing the current limitation. The incorporation of tactile feedback and anthropomorphic design will make the system more intuitive and efficient for surgeons. The addition of intelligent feedback mechanism use cost-effective 3D printing technology will further enhance the system efficiency and usability. Moreover, the integration of IoT technology with provide advanced capabilities for remote motion control, allowing the real-time adjustment and data analysis. This can lead to significant improvements, surgical outcomes, and patient safety. And the conclusion. Our robotic manipulation IRM represents a significant advance in robotic surgery technology. By combining innovative design, advanced material, and intelligent system, we aim to create highly functional, cost-effective solution for modern surgical application. This development promises to improve precision, safety, efficient surgical procedure. We are confident that our approach will open the new field in robotic surgery, marking complex operation for feasible and safe for patient and surgeon. Thank you for your attention.
Thank you for your report. Dear colleagues, please ask your questions, if any.
I have one question.
Yes, please.
Please.
What microprocessor do you use to control the robotic arm, and what are its advantages?
This is our first prototype, and we use a mainboard Arduino Uno R3 and processor Atmega 328P. But to the next step, I think that we try the more large processor, maybe Raspberry Pi 8 or another.
Thank you.
Thank you.
Maybe any other questions, please? No questions. So thank you for your report. And the next report is information system for detecting low-flying air targets and predicting support trajectory, authored by Mikhailo Strembitsky, Mikhailo Palomar, Vitaly Batyuk, Andrei Tchaikovsky, and Irina Plavutska. Please, other speakers present here.
Yeah, we are present.
Okay, so please share your screen and start your.
Okay, so our work is titled Information System for Detecting Low-Flying flying air targets and predicting their trajectories. So image recognition is used in various fields, including military, security, medical, manufacturing, etc. Such tasks include clustering, image classification, and object tracking. For some of these tasks, it is important to capture and predict object trajectory. In recent time, Ukraine's air defense needs to fend off intense combined air attacks. That includes kamikaze drones, cruise missiles, ballistic missiles, hypersonic missiles, and possibly other targets. Such intense attacks can deplete air defense capabilities and finally reach their target. One of the main problems with these attacks is the use of kamikaze drones. They are cheap and hence they are mass produced and mass used. They are relatively slow, and it means that it is impossible or very hard to hit them with conventional airplanes, modern airplanes, because of very intense difference in their speed. They are relatively cold, and it renders infrared homing completely or quite useless. They have a low radar cross-section, and it means that they are hard to detect. Moreover, they can circumflex the terrain, hide in the folds, and that all lead to depletion of air defense. That means that we need to imagine to find a new and cost-effective system for fending off such targets. So this research aims to develop an information system for detecting low-flying air targets and predicting their trajectories. The overall system overview is presented on this image. So it consists of, besides objects that we are trying to track, technical vision system, motion control system that controls vision system and also control the device for object interaction, and part of software that control the motion control system and also process information from a technical vision system. All this is we use look-back feedback in order to track the object and be able to combat it. We develop a prototype and sample software that is able to track the recognize and track the object that we are looking for. On this image, in this illustration, you can see thermal images of model objects and a green square that indicates tracking of that object while it is moving. On the slide, you can see a graphical representation of the results of determining the object contours and the way we can track and determine this object. So finally, we can say that we are under development of the system for recognizing objects by their thermal images. Special software processes the data from the thermal image camera, calculates the deviation of the image from the observer center, and sends the control action to the motion control system. That helps us to track the object and to keep it in the center of a field of the view of the thermal image system. The application of visual control methods makes it possible to adapt the operation of the device due to the widespread use of visual information about the state of low-flying air targets and prediction of their trajectory. Thank you.
Thank you for your report. Dear participants, colleagues, questions, please. Maybe you have some questions asked, please.
I have the question. Well, thanks for your report, very actual theme. I think, yes. So my question is such, how is that trajectory predicted out of only 2 coordinates? Thanks.
Okay, so actually we are predicting or extrapolating trajectory of the object only by 2 coordinates, and obviously it is not possible to reconstruct the trajectory out of only 2. So we have some degree of uncertainty where the object actually is located. That is not a problem when someone wants to use laser radiation for combating such objects, but it is quite a problem when we use projectiles that have limited speed and can't reach the object instantly. So in such a case, combating the object becomes a more stochastic process, and we have to make many tries in order to combat it, but nevertheless, I think that it is possible. On current state of our project, we did not test it. We haven't tested it yet. Thank you.
Okay, thank you.
Dear colleagues, maybe other questions? No questions. So thank you for your report. And the next report is Aircraft Automation Principles as a Basis for the Use of Information Technologies, authored by Leonid Romaniuk, Martin Bernas, Vitaly Kartashov, Igor Chihira, and Galina Toleidan. Please present your work.
Yes, we're ready. Presentation. Please. Share it? Yes. There. Yeah. You saw our presentation?
It's uploaded. Yes, we can see.
Wait a moment. Yes, you can see the first slide. You can see. Okay, we start.
You're welcome, please.
The ability of autonomous aircraft to follow trajectories with a small spatial trajectory displacement is required for this type of aircraft, which should be met in the vast majority of applications, in fulfillment of which ensured that UA does not encourage obstacles, does not violate of boundaries of designed airspace, mounted separations from other air traffic participants, or provide good recording due to the accurate positionings of carried sensors such as cameras. The consequences of influences short optical distances can range from missing missions objectives to safe critical events such as invasions into the undesigned airspace, or especially in the case of low-flying UAS, collisions with the aircraft obstacles. The idea of reducing complex relations to parameters of kinetic motion models was concluded that in order to create a reference trajectories for the parameter of kinematic motions model should not be derived from the detailed records of measurements of all system and subsystem states from detailed knowledge of the system. Probably the idea that it directed determination of certain parameters of kinematic model motions is sufficient for reference trajectories creations. Next. Accurate trajectory planning required information about the kinematic dynamic mode of unnamed aircraft motion for its proper trajectory planning. In this paper, kinematic model of Dubin's aircraft motion is used to reference trajectory planning. The reference trajectories what a planning using the Dubin's model motion are described in detail. Scenarios including obstacle settings, and the applications of a motion model is particularly suitable for efficient in-flight trajectory planning. For unnamed aircraft, reference trajectories can be created by determining kinematic model parameters during the nominal flights over the roof terrain and adaptive trajectory planning by means of a model of the Dubin's aircraft motions with the static wind, even if the parameter of kinematic model are known with the errors only in the advanced. You can see the vertical trajectory shown in this figure. Figure 1b is the climb segment. The transitions between horizontal flight and climb or descents are modulated by sudden changes in the trajectory angle gamma. This is all in the trajectory speed Vk will be modulated by approximation through sudden changes in Vk as well. In figure 2, described calculation of reference trajectory with SCS segment taking into account Dubin's aircraft motions model present. While planning motions only in obstacle-free space, in addition to road segment by specific reference points A, B, C, complete reference roads can also be planned in obstacle-free space. For this paper, the calculation was implemented in C++ programming language. Calculation times of separate motions planning segments for the implemented SCS motion planning algorithm on the desktop on onboard computers are shown in the table. Calculations time for CSS motions planning with the Dubin's aircraft motions model with the static wind, and calculations time for simple straight CC road planning are shown in this article. Automatic trajectory planning using the Dubin parameters aircraft motion model with the static wind is effective due to application of a constant cyclic graphs. The local problems of planning SCS motions in a space without obstacle are represented viable free space on the graph structure is proposed to approach. This makes it possible to carry out intensive computation at all time in installation stage and perform only at fixed conditions in the planning stage. The present approaches was road planning solves the problem of removing after road planning, which is related questions how its actually curve radial of aircraft can be taken into account during planning and road only the trajectories move. This investigation, local road and virtual dual graph is introduced in this investigation. In case we can take into account the span of optical information about maximum spatial trajectory reached at the moment of flight is used. The assessment shows how obstacles have already been encountered can be taken into account when planning the overcount. Since the trajectory violations resulting in correct, sorry, excuse me, please be quiet, sorry. Since the trajectory dividing resulting from incurrent and parameterization of flight characteristics can be accumulated, the obstacle clearance adaptations in less suitable in considerations incorrect parameterization flight characteristics. The resuming trajectories devastations are not affected the obstacle clearance approximation. The implementations of autonomous trajectory planning in a basic requirement for various operation scenarios for named aircraft. The Dubin's motions model combined with the SCS trajectory planning algorithm variable framework for efficient UA navigations in complex environment was created. That's all in general. Thank you for your attention. Are you have any questions for our article? We can listen you.
Thank you for your report, dear colleagues. Be active, please.
I have a question.
Please.
Can you have a file programmed to fly automatically using the Dubin's method to overcome electronic variable to tune its starting points? Thank you.
Yes, I understand you very well. I can say, yes, we can make a route, we can flight route, can be arranged in advance, yes, but we can also reprogram our flight program, but it's still some problems during the flights. It always we have possibilities to lose the control over our aircraft. We can lose the signal, we can lose control of our height, speed, and position in the coordinate system. That would be a crucial loss, and in this case, we couldn't take our aircraft come back to our station. It would be a disaster. But we can program in before and during the flight. That's all.
Thank you. I understand. Thank you.
Thank you. Maybe other questions? No questions. Thank you for your report again. And I have a suggestion, and according to our program, to take a short break on a half of hour. And let's meet after break.
I think the reason of this was personalized is
Dear colleagues, please wait 2 minutes. We have a little technical problems. Okay, dear colleagues, let's continue our second section, second international workshop on computer information technologies in Industry 4.0. And the next report is structure and regularities of development information and intellectual capital taking into account acceleration of digital transformations in conditions information society, authored by Halina Nagornyak, Andriy Sverstyuk, Lyudmila Maluta, Viktor Khomeshin, and Katerina Khanov.
Good morning, dear colleagues. The
good
name
morning,
of
please.
my thank you so much for attention. Good morning, dear colleagues. My name is Galina Nagornyak. I am from Ivan Pulus Technical University. The name of my scientific article is Structure and Regularities of Development, Information and Intellectual Capital Taken into Account Acceleration of Digital Transformation in Conditions Information Society.
I'm
The
sorry.
relevance of
I'm sorry, may I? Could you please upload your presentation? Please press on share screen and select your presentation.
Excuse me, please, but I have some technical problems. My Viber is up down.
Okay.
And,
May I do it?
I can talk only. Excuse me, please. I sent my presentation for you, and can you help me with this problem, please? Yes, from the first page.
Can you see
Open
them?
from the first. Yes, all is good, but open please from the first page.
Okay,
Thank
but
you so
please
much. All is
tell
good.
me when I need to change the slides.
Okay.
Great.
Second page, please. Thank you so much for help. The relevance of the research is provided by high extent of development of modern economy of Ukraine in a combination with a lasting transformation. In the course of information of economy, the digital infrastructure at the different levels is formed. Necessary systems which are improved through implementation of new technologies and accession and a common information space and created. Current trends of digital transformation of manufacturing enterprise for the purpose of increase in its competitiveness assume active introduction in practice of digital technologies. Digital technologies become instruments of increase in effectiveness, performance, and efficiency of productions due to increase in the output and or reduction of the used resources. Digital transformation assumes change of a production system of the enterprise is a main auxiliary process which serve of technology quality control and the organization of work. According to the concept, the industry 440, production processes, structuring and services have to be digitized and integrated on the basis of mutual penetration of information technologies and the industry. Implementation of artificial intelligence leads to emergence of intellectual information technologies, which promotes change of organization structure of the enterprise, reduction of staff and reorientation of staffing in pursuance of new functions. At the same time, relevant, there is a scientific and technical problem of definition of rational deployment of human resources with intellectual systems and realizations of effective forms of the organization of work and the combinations of human-computer interaction in a common information space. The majority of the existing research in this direction are conducted within development of collaborative industrial robots and integration of information resources. Success of the enterprise depends on effective use of modern digital technologies in the main directions of the activity. In process of information technology development, the need for use of innovative methods of management and the organization of productions increases. Universal distribution and implementation of digital technologies at the enterprises leads to change in process of making management decisions, planning, the organization of production of work. A digital transformation in narrow interpretation represents process of implementation of modern technologies in process of the enterprise. Transformation is at the same time directed to improvement of the existing processes and to creation of competitive advantages due to change the creation of new technologies processes in the enterprise. Use of digital transformation and new digital competitive advantages due to change the creation of new technological process in the enterprise. Use of digital transformation and new digital competitive advantages due to change and creation of new technological processes in the enterprise. Use of digital transformation and new digital knowledge is a key factor to effective development of production. Transformation assumes change of the main, the auxiliary and servicing process of the enterprise, a production system, technological quality control, operation planning of production activity, the organization of workers. Next, please. In modern conditions, the information economic, which relies of knowledge, becomes the dominating paradigm of social economic development. The emphasis of knowledge as an essential resources of the enterprise significantly influenced organization structure of management, promotes emergence of network economy, the virtual organizations which in this regard improving competitiveness of economic entities at any stage of life cycle and effective management of human resources. Siege of new forms and methods of its organization arises a key question. The situation in modern business is such that it is harder and harder to provide constantly increasing cost of labor and to reach not only performance of function and to stimulate activity of personnel which provide the notable growth of effectiveness to information economy, the necessary initiative worker who was to increase in the competence and to innovative activity focused on the maximum Excuse me, if you excuse me, please, technical problems. Sometimes there are, because now I am in Poland, in Białobelsk University. Excuse me, please. The situation in modern business is such that it is harder and harder to provide constantly increasing cost of labor and to reach not only performance of functions and to stimulate activity of personnel which provide the notable growth of effectiveness. To information economy, the necessary initiative okay, please, next slide, okay? Thank you. The efficiency of the youth intellectual potential is the highest. The enterprise owns the big intellectual capital. So the intellectual potential gains properties of economic category only in the course of attraction to economic activity. That it is in the course of transformation in the intellectual capital. We agree with opinion CITNIC that the concept intellectual resources, intellectual potential, intellectual capital, intellectual property, which are closely connected among themselves. The given ratio demonstrates that intellectual resources are the primary source to the defining factor of development of the enterprise, and the intellectual property is a result of formation of the intellectual capital. It is established that the intellectual capital is the key instrument of achievement of competitiveness of the enterprise and is defined have set of human organization and information potentials. Next slide, please. Change slide, please. At analysis of the basic structural economic elements of the capital by what enterprise the company firm as its main components, it is possible to mark out the following forms of capital: material capital, human capital, structural capital, client capital. Under the material capital, in this case, it is offered to consider all that of tangible assets of the organization, including buildings, construction, the equipment. Please, the next slide. Generalization results, thank you for help, of a research of structure of the intellectual capital. It is possible to claim that practically all scientists allocate three the main components of the intellectual capital: human capital, structural capital, and client consumer capital. At the same time, each researcher in own way locates allocation of elements and relationship between them. The weak innovative activity in the spontaneous nature of structural and technological shifts, mainly under the influence of a global environment, cause a lack and indications of innovative development of the industry of Ukraine from world indications. Formation in the industry of inefficient and technological structure. In technological structure is processing industry, the share of products of high-tech areas and an insufficiency of volumes of production with high added value is compensated by way of increasing its import, deepening an import dependence of national economy. For the last 10 years, the import share in the total amount of internal consumption of industrial output increased from 42.8% and to 47.6%. In 2020, machine building products from 77.7% to 94.9%, metallurgical from 35.9% to 39.7%, food from 17.6% to 21.6%. Today, later, have developed non-material component is social products from strong cost industrial trends. It is possible to use development of the country. The system of the following criteria is for this purpose used. First, social and economic criterion. It is if in the society of more than 50% the population in engaged in service industries, the post-industrial phase of its development came. If in society of more than 50 of population in engaged in the sphere of information and intellectual services, society becomes information. In the world believes that change in economy occur mainly after the specific weight of internet users begin to access from 10 to 15% the population of the country. According to this criterion, the USA entered the post-industrial period of the development in 1956 to 1960. The state of California, Silicon Valley overcame this boundary in 1910. The beginning of new century of the USA was met by the following structure of employment: 75% in the sphere of information intellectual services, 25% in production of goods that in the agricultural sector. Finland joins post-industrial society 20 years later than the USA. Ukraine, as well as the international community is in general, by this criterion, is at an industrial stage of development. The companies which ignore possibilities of World Wide Web will stop being competitive. The internet is data on buyers, suppliers and potential workers, and 90% of information on them were collection within the last 2 years. Next slide, please. Help me, please. Change the next slide. Thank you. The discussion concerning equation of transition to information society is conducted since the beginning of the 1960s. Still, it is as a scientific concept has to inform standard and conventional definition. Mark out only its main characteristics. More than 50% of the population are engaged in the sphere of information services. Growth rates of the information sector of economy surpass rates of development of economy in general. Wide use of information technologies and products of information sector of economy is everyday life. Creation in form, information space, and availability to it all members of society. Welfare of members of the society, a bigger mature, depends on their education. Training becomes continuous process throughout everything life. The next, please, slide.
I'm sorry,
slide,
Mrs. Helena, I don't feel comfortable interrupting you, but please follow the time schedule. We are breaking the schedule a bit, and I want to ask you a little shorter, a little faster, announce the main results of your research, because we have a lot of report waiting for you, for us.
Okay, good. Excuse me, please, that I take your time. I understand that there is limit in my time. Excuse me, please. I change all slides and I will finish my presentation. Excuse me, please. I ask you only to change all my slides, okay? And because our colleagues have to see all my information about this article, and I will finish. There are many interest graphics, a lot of statistics in my scientific article. Okay, I will finish. 11th slide, please. Open 11th slide, please. In the course of, thank you so much. In the course of the analysis of statistical data of number of busy workers at all enterprises of Ukraine for 2013 to 2022, monotonous trends of change of the trend for the analyzed time period, in particular in the section of the enterprises for their size, were revelated. For from the above stated table to we see that on a linear trend, the steady tendency to increase in total number of workers at larger, medium-sized and small enterprises of Ukraine is observed. However, the general tendency to increase in number of workers at medium-sized enterprises of the country proceeding from an indication of costs and personnel is watched. A polynomial trend of the set order. We choose the forecast for polynomial model of the set order as the considered in model reliable. Thank you so much for attention. I will finish my talking.
Thank you very much for your report. Dear colleagues, maybe you'll have some questions, please ask. No questions.
I
Thank you again.
don't have any question to you. Thank you so much for help, for attention.
Thank you very much for your report. And the next report is multi-sensor analysis of cognitive signals for neurological disorders and diseases. Authored by Mikhailo Patrick, Vitaly Braus, Mikhailo Baczynski, Andrea Pierre Legrand, and Mykola Zayarny.
Good afternoon. I will be presenting this paper today.
So please.
Yes, do you see my screen, right?
Yes, we are.
Great. So, as you mentioned, our paper is called Multi-Sensor Analysis of Cognitive Signals for Neurological Disorders and Diseases. And today I will talk about firstly about our methodology. Second, we will take a look at the data collection and processing using the developed matrix algorithm. And lastly, we will take a look at the results of those calculations. So the developed multi-sensor system combines hardware and software in order to detect disorders caused by diseases or injuries, both industrial and combat related. And the system uses the new technologies to diagnose and treat neurological problems caused by previously mentioned reasons. The manifestations of such problems include abnormal neurological movements. By that, we mean uncontrollable contractions of muscles in certain parts of the body. In our work, those parts are the upper limbs or hands. And our methodology includes tracking position of the patient's hand. And at the same time, we record signals of cerebral cortex of this patient. For position tracking, we are using interactive tablet with a special electronic pen. And for recording, and then the recorded data is then processed and analyzed by the developed software. Here on the picture, you can see on the left picture, the device for recording signals from the cerebral cortex. And on the right picture, the tablet with a spiral and the pen for recording those movements. Here is the algorithm of of computing the adaptive coefficients. Here the matrix with gammas are the neural feedback matrix. The calculation of those values are described in more details in the paper. Then the matrix of S is the matrix of signals from the cerebral cortex recorded from the patient. And the alpha are the adaptive coefficients that we aim to calculate. And the U on the left side, those are the matrix that that is the result of our calculations, which we obtain the factor of solutions to establish the connection between values of amplitude deviation of the hands movement and the cognitive signals recorded from cerebral cortex. By doing some transformation, we can obtain the formula for calculating those adaptive coefficients. And to do that, we need to break the data recorded from those devices during the prolonged amount of time into the smaller chunks of 16, because when recording the data from cerebral cortex, we have 16 channels from different parts of the cortex. And then we break this data stream into chunks, creating the separate matrices to then calculate the adaptive coefficients and in the result combining them together. This is the picture that shows the software for analyzing the data recorded from the tablet and pen. Black on this spiral is the spiral that was a target for the patient to draw the curve around, and the red is the actual data recorded from the patient. This software allows us to do some noise cleaning and feed in data to get more precise results later. And here we can see the previous spiral, but in the polar coordinates. So the R is the target spiral that was displayed on the tablet, and in blue is the actual spiral drawn by the patient. Here we can see the deviation. Here, excuse me. Okay, I will continue. So here we can see the picture of the deviation from those two spirals. And here is the, after applying our calculations, our matrix algorithm, we get also the deviation with those coefficients displayed on this picture. So in red, this is the actual deviation shown on the previous picture, and in blue, this is the result obtained from our calculations. And we also tried different methods for processing the data, and later pictures show the different results we obtained from those different methods. And here is some calculation, some statistics from the data we processed. And as a result, we created a system that produces the high quality data on patients' behavior, and later this data is recorded, saved, and prepared for analysis. Yes, this is the end of my presentation. Thanks for the attention. If you have any question, I am ready to answer them. If no questions, then thanks for the attention.
Dear colleagues, thank you for your report. Dear colleagues, do you have some questions? Okay, so I have one question. According to the topic of your report, the concept of neurological disorders is large. It includes different types of disorders. Have you considered different types of different disorders, or only one?
Well, as mentioned in the presentation, those disorders can have different reasons. I'm not sure whether this answers your question, but maybe my co-authors can step in and answer in more details.
Okay, thank you. Other questions?
I can help Mykola with this question. Yes, my name is Vitaly Braus. So if we are talking about this paper, yes, the main idea that we are researching some disorders that we can research in some frequency range. Yes, so it means if we are talking about this data records that we receive from tablet, we know that commonly 6 to 8 hertz range is common for Alzheimer disease or similar diseases. Yes, so we are talking that we work on this range if we talk about data received from tablet. And also we filter all this data from Cortex and make some feature engineering that correspond to this range of data in frequency. So this is the main idea of this work. So the main data cleaning and feature engineering is work in this direction.
Thank you, I understand. Thank you. Maybe other questions, dear colleagues? No questions. So thank you for your report. And the next report is development of software for the implementation of automated reserve input modes operation, authored by Богдан Оробчук, Oleg Bunyak, Ivan Sisak, Sergey Babiuk, Igor Bondarchuk, and Vadim Koval. Please.
Is everything okay with this presentation?
All is okay. Please start.
Okay, the name of the article is Development of Software for the Implementation of Automated Reserve Input Modes Operation. The automated system based on the laboratory stand and software, which was implemented in the educational process for application of AMD device function, is considered in this paper. The device can be demonstrated without being connection to the computer. Instead, when the device is connected to the computer, the software analyzes the status of the AMD device using the Modbus protocol. The objective of the development automatic system based on the laboratory stand and software, which is will visualize the functioning of the devices of AMD product series during laboratory work. The students will have the opportunity to study the operation of the switch controlled by AMD device, get acquainted with the procedure of the data exchange during switching between the main and backup power supply links, and carry out the process of generator control. Feature 1 shows the main device of the laboratory stand without computer. Feature 2 show power electrical panel. In order to increase visualization and practical application, the development system was integrated into the training SCADA system energy of the hardware-software complex Arrow, which is designed as a simulator of the automated dispatch control system for research and control of the operation modes of electrical power system. To exchange the data between hardware-software complex Arrow and AMD device, the program based on the Modbus R2 protocol was developed. The communication channel is used to exchange data with the device of the laboratory stand. The data are transferred into the equipment model where the messages are proceeded. Next, the data are transferred to the real model where the final processing is carried out, fixing the message into the database, analyzing of emergency situation, and saving information about the current status of the model. During the work, the student uses the graphical model that provides a request for input of the real model and outputs in a form familiar to the user, mnemonic scheme, which is shown on figure 3. The developed program file to the Modbus R2 device map and AMD automatic control unit itself as the real model of the training SCADA system energy. To integrate this model into the SCADA system environment, the graphical model, which is shown on figure 3, and configuration file containing to the following data were created. The development and implementation of the software was carried out in Microsoft Visual Studio environment. The diagrams were created in the Borland Together design environment. The project schedule was implemented due to the Microsoft project, and the work of communication and Modbus register was performed using Modbus Pole program. The basic switch energy program consists of several modules, each of which perform its own task. The division of the program into categories and modules is shown in figure 4. The power connection of the primary and secondary sources and the load are graphically represented in the program as well, figure 5. While using the program, the student observes the control status of the generator, which power source is connected to the load, which electrical lines are energized. This information is transferred from Modbus bus and is used as update to charge reflect the real status. In animation is the operation mode of the program. Then the chart graphic is created on the basis of Modbus bus data due to Modbus data injector subprogram. The software representation of the line on the diagram is quite time-consuming during programming. In the real device model, the animation of the lines is not displayed, and the connection of the lines to the power supply is obtained directly from the Modbus request data. Animation is not displayed in the operation mode of the real device. The student is able to observe the current situation and change in real network. The communication connection between the device and computer is created by means of required converters, the type of which depend on the computer configuration. Communication between OMD device and computer take place according to the Modbus protocol, where the main device sends the request to which the involved device responds specified in the request. Schematic explanation of the operation of the presented automated system equipment is shown on figure 6. The general view of the proposed software is clean and visual. It contains 3 images with the diagram. Voltage on the electrical conductors, the statuses of the main switch, as well as the commands from OMD device to the generator and electrical network. The view of the program where the diagram with colored lines clarifies the information is shown on figure 7. The image describes the condition of primary and secondary links of the electrical network and the equipment connected to the load. The program graphic consists of electrical circuits, red and green lights in the diagram, OMD device, and load switch that performs the switching. OMD device controls the generator of the second power sources, blue line. In addition, the program has 3 images showing the primary power supply top left, the secondary power supply top right, and the training lab load connected to the power supply sources, bottom middle. Colors and brightness of image change depending on the activity of the device or image object. The view of the program window is in the function presented. The model is shown in figure 8. Light indicator shows the receipt of electrical energy by the laboratory equipment. What is shown on figure 9. The objective is to develop automated reserve input system based on the laboratory stand and software for communication with OMD switch control produced by ABB company. The developed software is very simple and support illustrative and educational application. The developed program has 2 modes of operation, with and without OMD device. The program graphic makes it possible for the student to get acquainted with the function and capabilities of OMD device and additional function, in particular exchange animation and wallpapers. Language selection is available too, English or Ukrainian. The connection of external equipment OMD is designed in accordance with the requirement of switch energy program using Modbus protocol. Information transmitted by protocol about the current status of OMD device can be presented in the program both graphically and verbally. The animation model has also been developed for the program. It makes it possible to present the functions of the device without physical connection to the device. Thank you.
Thank you for your report. Dear colleagues, questions? Any questions, please?
Good afternoon. I have a question. Can I ask you to
Yes.
back to figure 9?
Yes.
Please tell me in more detail the implementation of the mode of a real device shown in this picture.
Okay. The model of presentation of the necessary device does not require additional action for the student. Communication with the armed device is established automatically without setting additional option in the program. Real-time information about the state of power sources, power supply of the load, the position of the electrical switch of the load, and the state of generator is presented graphically from the program, as well as in animation model.
Thank you. Thank you.
Thank you too.
Maybe other questions? No questions. So thank you for your report. And the next report is real-time air quality management, integrating IoT and fog computing for effective urban monitoring. Authored by Andriy Stanko, Wojciech Wikzorek, Andriy Mikityshin, Alexander Lutenko, and Taras Lechichenko. Please, you may make your report.
Good afternoon again. Can you see my screen?
Yes, we can. Please.
Okay, thank you. Let's start. Dear colleagues, we bring to your attention an article on the topic real-time air quality management, integrating IoT and fog computing for effective urban monitoring. Next slide. Air pollution is a major issue that negatively impacts human health and the environment. Key pollutants include carbon monoxide, nitrogen dioxide, sulfur dioxide, methane, and atmospheric particulate matter. Monitoring air quality is critical for quick decision-making to mitigate these effects. The aim of our research is to enhance the accuracy and timelines of air quality data using IoT and fog computing technologies. The Air Quality Index, AQI, is an important tool for communicating air pollution levels to the public. It converts pollutant concentration into a single index value that indicates health risk. The AQI is structured to reflect increasing health risks with higher index values, using a color-coded system for clarity. Effective air quality management relies on comprehensive monitoring networks. These networks consist of stations that measure pollutant concentration, providing data to develop and implement plans for reducing pollution and protecting public health. In the European Union, there are established standards and objectives for several pollutants, requiring continuous monitoring and public reporting. In Ukraine, monitoring is governed by older guidelines, focusing on maximum permissible concentration, MPCs. Comparing actual concentrations with MPCs helps assess air quality. As IoT adoption expands, so do its challenges. IoT devices generate vast amounts of data that need a quick processing, which centralized cloud models cannot handle efficiently. Fog computing addresses this by processing data at the network's edge, improving efficiently, reducing data volume, and minimizing latency and bandwidth usage. This is illustrated in the structure of fog computing in this figure. According to the definition of data quality dimension clusters, the main problems faced in managing data from regional agencies are as follows. Completeness, heterogeneity of data format, and heterogeneity in time and types. Redundancy. Some data sets includes multiple versions of the same record type. Availability. Some regions provide the data set through the websites of their remote control authorities, while other regions provide the data through open data portals. An air quality monitoring system provides the end user with real-time data in a simple format. A variety of sensors are available to collect atmospheric data. Temperature sensors, humidity sensors, rain sensors, carbon dioxide sensor, dust particle sensor, carbon monoxide sensors, etc. Next one. Our tool is based on a specific data model, which data processing and visualization tasks can be performed in a rigorous and consistent manner. A dimensional fact model, DFM. This conceptual representation consists of a set of fact diagrams that basically model the analyzed domain in terms of facts, dimensions, measures, and characters. The combination of three dimensions, time, location, and pollutant type, results in several potential views of the same fact, allowing it to be viewed from different perspectives. You can see on a figure. A cyber physical system, CPS, integrate physical sensor with computational elements to monitor and manage air quality. CPS leverage IoT devices, mobile sensor, and wireless network to provide real-time data and insight for environmental management. The IoT connects physical and virtual objects through sensor and softwares. For computing process data at the network edge, reducing latency and bandwidth requirements. Together, IoT and fog computing enable efficient real-time data analysis for air quality monitoring. Transforming raw data in essential for recognized data from regional environment authorities. To achieve a fast data loading and effective visualization, we offer a set of dashboards tailored to different stakeholders: citizens, researchers, environment control officers. This dashboard include various charts and filters, providing access to different views based on the user role. Generally, the structure includes a summary page of main details, followed by specific analyzed data for each pollutant with filters based on time and location. The system architecture consists of 4 layers. The first layer is the IoT layer, includes devices capable of collecting information about the environment. Second, the data layer is designed to process, integrate, and store heterogeneous data sources. Third, the business layer is a central processing layer that executes a business logic and interacts with the storage layer. And the last one was the interface layer between the system and the end user, which manages all services related to user interaction. And summary, our research presents significant advancement in air quality monitoring for the integration of IoT and fog computing technologies. This innovation offers real-time data processing and enhanced accuracy, which are critical for effective urban air quality management. By addressing air pollution more promptly and presently, the proposed system can significantly benefit public health and environmental sustainability. The integration of European Union methodologies with Ukraine community-oriented approach provides a robust framework for future developments. Further research should focus on enhancing sensor networks, incorporating machine learning, and fostering transparency collaboration for continuously improve of efforts of air quality monitoring system. Thank you for your time, that's all.
Thank you for your report, dear colleagues. Any questions, please?
Yes, I have one question, please. Can I ask you?
Yes, please.
Mr. Holotenko, my questions is only one and is the next. How does the integrations of IoT and fog computing specifically enhance the accuracy and timeless of air quality monitoring compared to traditional methods? Thank you.
Thank you for your question. The integration of IoT and fog computing enhanced the accuracy and timelines of air quality monitoring by leveraging real-time data collection and localized processing. So IoT sensor deployed through the urban environment consistently collect data on various air pollutants. This data is processed at the edge of the network using fog computing, which significantly reduced latency compared to centralized cloud computing. By processing data closer to the source, fog computing ensures quicker response times and more immediate feedback on air quality, leading to more accurate and timely decision making. Additionally, localized processing helps filter out noise and anomalies in the data, further improving accuracy. That's all.
Thank you. Thank you.
Thank you.
Thank you for your report. Maybe another questions, please.
Well, if I may.
Please welcome.
Thank you, Mr. Chairman. It's rather a comment, not the question. So the speaker presented very effective and robust approach to scale up networks for monitoring equality, and well, maybe he will either support or dismiss my suggestion that if authors combine very different and homogeneous devices in that edge level, then some procedure for data cleaning and validation is to be implemented in the fog. So is it the case?
Thank you for comment.
Okay, thank you.
Thank you for your questions. And the next report is a development of digital twin interface for Industry 4.0 production line, authored by Yuri Skurenki, Viktor Vodchuk, Tatiana Vitenko, and Alexander Kramer. So please start your report.
Thank you. While I'm yes, I'm going to share my screen. I suppose I have permission to do so. And screen sharing. And while I'm sharing my screen, I would like to thank the organizers to present, allow to present my. I suppose you can see my screen. Can you confirm that?
Yes, sir, please.
Great. To present some preliminary results of development of digital twin interface, which was undertaken by two research groups in Ternopil National Technical University, with a goal to, say, streamline the introduction and implementation of Industry 4.0 practices. As you surely know, the smart manufacturing is the very, say, perspective direction in Industry 5.0, in which not just products are outcomes, but also flows of data, and not just materials are input vectors and input sources, but also some data and standards, as well as different kind of incoming signals here. So we have to deal with the complex and homogeneous system in which different production devices and mechanism and equipment and IoT devices collecting all kinds of data in order to optimize production and assemble all kinds of important data. They all must be treated as the in a holistic way, as the complex but unified system. And as an example, as the say pilot for our study, we have chosen one of the production lines in the metal processing plant, in which the central equipment, the central stage of production was the automatic welding machine. And to control the production and to manufacturing actions taken by this welding machine, operator must have all kind of different data which are not readily available and which can be looked and misunderstood easily. So the whole process was represented as this diagram, in which we have different phases of manufacturing, and in many phases we also do some accompanying measuring. Measurements are very important here. They provide lots of quality, maintenance, consumption data, as well as they allow us to in future implement such important thing as European product passport. So we have to collect those data, not just to optimize the production process, but also to provide complete information and precise information about the process life cycle. So those data were classified, and really, as was mentioned by the previous speaker, we have here the issue with very inhomogeneous data which come in variety with different velocity and are to be cleaned, processed, verified, stored, and this is the problem of its own. But all these kinds of issues are to be considered and tackled before we implement this kind of digital twin. And our digital twin, let me remind you, is to allow the operator to control the process and to respond timely to all kinds of problems and external signals. So the digital twin architecture was chosen, in which the most effective interface, in our opinion, would be augmented reality interface. Therefore, we have not just this digitized industrial platform in which we acquire those data from IoT sensors, from embedded devices, from all kinds of machinery, but also we have to implement some interfaces to knowledge bases. And we also have the mechanisms, the interfaces between human and machine. Those human and machine interface require processing power. This processing would be implemented in cloud, of course, because on-premise devices oftentimes do not have computing power and possibilities to realize those. But still, this architecture allowed us to, say, start implementing and to build, first of all, augmented reality design. And of course, this starts from kind of visual and effective representations of these parts of mechanisms, which are easy to recon and to respond by a human being. And then we overlay information in the textual form. And of course, we use coloring to say stress importance of such information, and some critical levels are here also signaled by additional audio information and visual signs. And this is what we call augmented reality layer. So we have augmented reality application implemented into the digital twin, and that is the novelty. That is the breakthrough which allows operator to respond timely, to switch to different modes of operation, to prevent all kinds of hazardous situations. So I will not take much of your time for conclusions. Just in short, contemporary state of the industry allow us to modernize lots of legacy systems and production lines to the level of the industry 4.0 with relatively low say additional resources involved. And in this respect, digital twins are already say the optimal choice for our industry partners to embark on this Green Deal and European integration platforms. Thank you. Thank you for your attention. I'd be delighted to answer questions if there are those.
Thank you for your report, dear colleagues. You may ask your questions, if any.
Yes, I have a question.
Yeah, please.
You mentioned Industry 5.0 and Industry 4.0. What is the difference between these two, I guess, generations of industry? Or
Thank you, Professor Kochan. Really, it is my favorite. Thank you for asking specifically this question. And you probably mentioned that I just focused on Industry 4.0 because to implement specific features of Industry 5.0, which are, say, inclusion of human creativity and all kinds of specific mechanisms allowing human to be on par with automation, the important, essential part of this production process. For example, customization and lots of different particular features of Industry 5.0. Here, we really need much higher resources to be included and to be used in developing this Industry 5.0, not just prototype, but production lines. Unfortunately, especially in current conditions, our industry partners do not possess those resources, and we consider Industry 4.0 just as the necessary step of modernization, which will allow our partners, this metal production line in particular, later to implement the new levels, Industry 5.0. Of course, this problem may be not so acute for European industry, but here in Ukrainian conditions, we have to first tackle the first step, the digitalization and further automation. Inclusion of different kind of smart sensors, IoT devices, and only then we'll move on by including human operator as say more important factor in the production. And thank you again for your question.
Thank you for your response. And may I ask one more question? I think it will be short. How long do you estimate it will take for enterprises fully implemented Industry 4.0 approach to move further for the next generation to Industry 5.0?
Well, that's very important, but also very complex question. In the case of, in our particular case of this single enterprise, it took us about 4 months to build the not the full digital twin, but essential modules of this digital twin. And of course, it depends on the resources we may attract, we may involve and apply to this problem. So even for single enterprise, it will take, say, half a year. But for industry of the whole country or the continent, as we know from history, it takes decades, and this time is not available for us. So probably we should implement more differentiated approach. So those industries which are more, which are better prepared to this transformation may take this step and may succeed in a year or two. But other industries will, say, have to adapt. So that's the best question I can afford.
Thank you for your response.
Thank you very much again.
Thank you. Thank you for your report and your answers, wild answers. And I would like to invite our Chinese colleagues to the next report. The study of rapid identification of medical vector organisms based on improved transformer. Are the speakers present here?
Yes, wait a minute.
Yeah, please. I'm sorry, but we can't hear you.
Good afternoon, everyone. Now I introduce the article, a study on application of medical vector organism based on improved transformer. Accurate and timely identification of medical vector organisms at ports of entry and exit is an important issue in the work of customs and exercise department. Among them, flies, mosquitoes, and cockroaches are important parts of vector organisms. Therefore, it is a meaningful task to conduct research on the identification of vector organisms at ports of entry and exit. The traditional measures mainly relies on the experience accumulated by the staff in the actual identification work, which requires the staff to match the physical and morphological characteristics of the vector organisms distinguished by the naked eyes, always the help of microscopic magnification equipment. with the descriptive text in the books on species classification, which is very much dependent on the practical experience of the staff. However, due to the large number of vector organisms, some vector organisms have similar characteristics, and the staff are not all experts with rich practical experience in identification, relying only on the staff's experience to determine the types of vector organisms, especially in the initial screen stage of the sample size is large. There is a slower speed, more real-time, and subjective, so that the impact of the fresh sample morphologic identification of the detection of the problem of the initial screen, making this method very time-consuming and labor-intensive. In this paper, we use 3 sets of network models with exactly the same network structure. The number of transform layers is 243. The dimensions are 64, 80, 96, and finally a group of points of point convolution is performed to reduce the feature map. The overall architecture in the model is shown in Figure 1. The network structure is shown in Table 1. Only the input dimensions of transformer are different from sub-VIT input. The input token is 64, 80, and 96. Improved sublet structure schematic is shown in Figure 2. In contrast, the ILU6 activation function is limiting the ILU function to a maximum output value of 6, which allows for excellent numeric resolution on low precision devices. When the ILU function is not limited to a maximum value, it will not be able to accurately characterize a large range of values on low precision devices, resulting in a loss of accuracy. The use of the H-switch activation function reduces the number of parameters compared to ILU6 and H-switch. Each pixel operates attentively only with the other pixel in the same position. The number of sequences formed in the pixel value of each block, assuming that the width, height, and the number of channels of the feature map are H, W, and C respectively. Then the number of sequences in each sequence is W multiplied H divided by P, and P is the size of the block. Transformer operation is performed on the model after obtaining the sequence. In this paper, we use a dataset which contains 3 species of cockroaches, 6 species of mosquitoes, and 20 species of flies, with a total of 338 image datasets, and the background of the images is a single unobstructed environment in the laboratory, where the various categories of vector organisms are displayed in the form of p-inserted specimens. The dataset suffers from uneven distribution of the number of images in each category and the differences in angle of vector organism display, with the number of sample images in each category ranging from 9 to 53. Figure 5 shows the main categories of the dataset displayed. The results in Table 2 show that CITI outperforms other convolutional neural networks. For the ResNet series of convolutional neural networks, CITI outperforms ResNet 18 by 1.33%, ResNet 34 by 1.03%, and ResNet 50 by 1% in the accuracy of the image classification task. For the MobileNet family of convolutional neural networks, CITI outperforms MobileNet V1 by 4.03%, MobileNet V2 version 1 by 3.24%, and MobileNet version 2 V2 version 2 by 1.58%, MobileNet V3 Large by 2.31%, higher than the mobile V3 small and 5.45% higher than mobile V3 small. For the Chevrolet family of convolution neural networks, Chevrolet VIT is 12.83% more accurate than Chevrolet V2. The article proposes a new low-weight image classification network model for vector organism recognitions. Firstly, a fusing model is introduced to replace the depth-wise separable convolution in the Chevrolet with a regular convolution 3x3, and H-switch is used to replace the ILU activation function, which reduces costs while better reducing the number of model parameters. Then this article uses a network architecture that combines convolution and improved transformer to input images in sequence into the transformer to obtain global feature information, ensuring that the network model can extract local and global features of the image. At the same time, the transformer is improved to reduce the number of model parameters. That's all. Thank you for listening.
Thank you for your report, dear colleagues, dear participants. You may ask your questions, if any, please.
May I, Mr. Chairman?
Yes, please.
Okay, so dear authors, sources, thank you for your presentation. I actually have lots of questions, but these are maybe not to the essence of your talk, but about the data and their quality. I'd like you to comment shortly on how the data set is collected and whether the cleaning and validation are performed within the platform or externally with help of external services.
Well, actually, the data set is collected by first at the beginning, the faculty at the exit will get the picture of the mosquitoes, flies, and something like that. Then they will send. Actually, they will froze the animals and send them to a laboratory. And in the laboratory, then the researchers will take pictures, use the macro. Let me see, what's the question?
Okay, I see. But you have shown us very high quality pictures, and if you use coordinated.
They use the. They get the pictures with high resolution.
I see. Because my second question is related to the previous one. You have shown us accuracy levels of order of 80%, and if this level is considered to be acceptable, what happens in case of false positive when, say, quality of pictures is much lower?
Yeah, because the database is very small. As present in the PowerPoint, there are only 338 pictures because so far they could not support many pictures. That's why the precision is not very high.
Thank you. Thank you very much.
You're welcome.
Thank you for your question. Maybe another questions? Thank you for your report. And the next report and the last report for today and for this workshop is coarse contrastive recommendation algorithm based on hypergraph convolution. Are the speakers present here?
Yes.
So please, you're welcome.
One moment, please. Can you see my screen?
No, we can't. I'm sorry.
Not yet. Maybe the previous speaker should end his screen share. So, Yanju, can you end the screen share by stopping sharing your screen? Mr. Speaker, maybe it will be the only well, reasonable way to just
I'm sorry, but you have to have a rights for change a screen, to share a screen. Yes, yes. Press on green button.
Share screen. Yes, I pressed it, and I chosen
and select your presentation.
Mr. Chairman, please remove. Oh, that's
yes, all is right.
Is it now okay?
Yes, all is okay.
Okay, so my presentation is entitled Coarse Contrast View Recommendation Algorithm based on Hypergraph Convolution. The recommendation systems are one of the most successful applications in the fields of data mining and machine learning. They provide users with personalized platform services that meet their needs. They also can be useful for enterprises by increasing their revenue. However, the performance of most recommendation systems is far from ideal. This is connected with several problems such as high cost of data collection and complex information about the interaction of users and items, and also the sparse data of effective user-item interaction. Despite quite good results exhibited recently by the recommendation systems, there are several problems with the recommendation system. The most important are listed here. The first is the problem that recommendation systems rely on users to generate their own data, which makes it difficult to obtain effective labeling information. And the second problem is that graph convolutional network-based recommendation models are susceptible to the noise of user-item interactions. To cope with these problems, we propose our own model, which consists of three main modules. The first module here is a hypergraph convolutional model. In this model, we adopt graph augmentation to obtain new views of user-item interactions. After that, for two views, we construct a user hypergraph set and the item hypergraph sets for online view and for and use this module to produce hypergraph set and item hypergraph set for target view based on interaction information obtained from data sets about interactions between users and items. Then, similar to the known methods, the characterization of users and items is carried out using the convolutional operation. The second model is a momentum-driven twin network-based model. Both online and target networks, use the gated dual hypergraph-based convolutional model as the network structure. We use the momentum update mechanism to optimize the target network's representation learning model during the parameter training. This aims at utilizing the characteristics of momentum update mechanism to encode historical information in the target network, and thus we can guide online network to learn to explore richer and more effective feature representation. At the same time, the symmetry of comparison network is enhanced by this parameter updating method to alleviate the possible training collapse problem. Negative sampling training strategy based on course learning is used to solve the problem of too much randomness of negative sampling in contrast learning. We introduced the method of course learning. In the negative sampling process, first we introduce the scoring function here to sort the negative samples from easy to hard. And in addition, we use also the pacing function, which is used to control the negative samples into the training process. Then the mutual and consistency information between two views is maximized. Then we train the system, the model, and finally we can use the trained model for making predictions. Dual hypergraph convolution model mainly uses two chi sub-hypergraphs in online and target views to obtain the potential features of users and items behind different interaction types. It is obtained by aggregating and propagating the future representation of users and items through the hyperedge aggregation and propagation of corresponding hypergraphs, which were constructed on the basis of different interaction types in two hypergraphs through convolution operation. To study the efficiency of the proposed model, we use two real-world data sets from Amazon and Alibaba, and statistical parameters of these data sets are given in this slide. To comprehensively test the performance of the proposed model, we study the following, we carry out the following experiments in this paper. The first is comparison of performance using the chosen metrics with the known methods. Second experiment is ablation analysis, in which we study the contribution of each component of the proposed model to its performance. And the third is hyperparameter sensitivity analysis, in which we study the effect of the hyperparameter on the performance of the model. The first experimental result, the results of the first experiment are given here. We can see the comparison of 8 methods using 4 chosen metrics. The 4 metrics were checked for both data sets, and we see that the simplest methods, which are based on simple homogeneous graphs, performs poorly, probably because they do not deal well with non-planar relationships between the nodes. Better parameters are showed by these 3 methods, but this dual HGCN works best among them, because it can better capture the interaction information between different interaction types by designing the information transfer mechanism between hypergraphs. But the best performance is shown by the proposed model for both data sets. So this experiment confirms that the proposed model is effective. Then we run the ablation test to check the influence of components of the model on its performance. And here we see the table with comparison. Init is the only feature in its initialization model only. And we see also 4 chosen metrics and comparison for 2 different data sets. And we see that in this case, the performance is not very good. When we introduce the gating-based dual hyperloop convolution model, we see considerable improvement of the performance. When we add the momentum-driven twin network and comparative learning, we see further improvement of the performance. And the last stage is negative sampling strategy was applied for the complete model. And we see that in this particular case, the performance is best. And the third test is to test the effect of hyperparameters on the accuracy. Here we have beta, one hyperparameter, and also we check the influence of value of beta, which changes from 0.1 to 0.9 with the step 1.9. And we check 4 chosen metrics for 2 data sets. And we see that when beta value is 0.5, the performance is best among all other possible values. So we chosen beta 0.5 for the best, most effective operation of the proposed method. Thank you for your attention. Now I'm ready to answer your questions.
Please, dear participants, dear colleagues, any questions?
If I may ask, I just say I'd like to use this opportunity to ask the expert in the field, maybe more general question, and this is about your estimate of the percentage of synthetic data used for machine learning-based recommender systems.
In fact, these data sets are taken from a real-world operation of 2 websites, Amazon and Alibaba. So
but generally, how do you assess? What is your estimate? How much of synthetic data are already being used?
We used the. Do you mean what is the most effective size of the data set, or?
If you can, yes. If you can assess this.
No, well, actually, this the more data, the better. But I think we tried a lot of data sizes, and we chosen that we found that about these data sets are the best because training speed and accuracy is best for the data sets like these.
Okay, thank you.
Thank you for your question. Maybe another questions? Okay, thank you for your report. Dear colleagues, all the reports scheduled for today have been presented. On behalf of all the workshop organizers, I want to thank you for the great work done. This concludes the work of the second day of the workshop. Tomorrow will be the final session of the workshop according to the program. So have a great day, everyone, and stay safe. Goodbye. Thank you. Thank you for your work.
Thank you. Have a nice day.